What's up, team? Today we're talking polynomial terminology. You see the learning target right here. It says I can identify parts of a polynomial and determine what degree the polynomial is. So this is going to be a lesson where I'm going to give you a whole bunch of definitions. They're going to pop up on the screen in the video here. I recommend writing them down. I think they're valuable. So it's a lot of writing. We're actually doing zero math today. Today is just pure definitions. So I'm going to point at things. There's a polynomial on the board behind me. I'm going to point at it. I'm going to show the different parts as I'm showing the definitions. So let's get right into this. The first thing we need to define is the word polynomial. So polynomial is the sum of one or more terms with whole number powers. This example on the board has a number of terms with whole number powers. Powers, of course, is exponents. 9 is a whole number. 5 is a whole number. 4, 2. And this one, you could argue has a whole number power if you said like x to the 0 as power or something like that. So these all have whole number powers. Now the word terms, let's do a quick review on that. A term is an individual piece of a polynomial separated by an addition or subtraction sign. So again, this is our polynomial. There's a term right here. 5x to the 9th is a term. This is also a term. 2x to the 5th, 2x to the 4th, 11x to the 2nd, and 3. There's 1, 2, 3, 4, 5 different terms here. So term is just some expression. It could be it could have numbers, variables, exponents, whatever. It's separated by addition or subtraction signs. Let's keep moving. A coefficient. A coefficient of a term is the number that's being multiplied by the variable. For example, this term right here, this term 5x to the 9th has a coefficient. The coefficient is the 5. So that's the number in front of the variable, the number being multiplied by the variable. The coefficient for the second term is 2. The coefficient for the third term is 2. Coefficient for the fourth term is 11. And the coefficient for this last term, there is no coefficient because there's no variable present. But we do have a special name for that word at the end, for that term at the end. That's a constant. A constant term does not have a variable. It doesn't change. So in this polynomial, if we plugged in some value for x, we could simplify and get a value. But this term out here is not going to change no matter what x equals. X could equal 0, x could equal 100, x could equal 56.2, I don't know, whatever. And that 3 is still going to be 3 no matter what. So it's a constant term. It's never changing. The degree of a term is determined by the exponent attached to the variable. So let's go through each of these. This first term right here we say is a 9th degree term. It's the term with degree 9 because the exponent is 9. This term is degree 5. This term is degree 4. This one's degree 2. And again, this one's a constant, so you could argue it's degree 0, but generally you would just say it's a constant, so it doesn't apply. There is no degrees for this term. Degree of a polynomial. The degree of a polynomial is determined by the term with the greatest degree. So if you were given a polynomial like this and the question says, what degree is this polynomial? Well, you look at all of your terms, no matter how many you have. In this case, we have 5. You find the one with the largest degree. So you just kind of look at them like, well, there's a 2, there's a 4, there's a 5, and there's a 9. Oh, bingo. 9 is the largest exponent that we have. So we say that this here is a 9th degree polynomial. And again, there's nothing special about this particular polynomial. This is just random numbers that I made up, but it's a great, it shows what we want to show here. Okay, we're getting close. Standard form of a polynomial. That's when terms are listed in descending order. So this means that the term with the highest degree is listed first, and they go down from there. So this is already in standard form. Sometimes you're given polynomials not in standard form, and you need to rearrange them. Your practice problems today are going to have stuff like this. So again, I just want to point out, 9 is the biggest exponent. This is the highest degree term. 5 is next, and then it's 4, and then it's 2, and then our constant. So this is already listed in standard form. It just means you put the bigger ones up front, and then you work your way down. And you're looking at the exponent, not the coefficient, when doing standard form. Okay, we're getting close. So if we know what coefficients are, well, then what's a leading coefficient? The leading coefficient is the coefficient that's in front of your leading term when in standard form. So this thing is in standard form. The biggest term is out front. In this case, it's a 5. So we'd say 5 is our leading coefficient. Now, 2 and 2 and 11, those are also coefficients, but they're not the leading coefficient. So the leading coefficient is the coefficient of the term that's out front when it's in standard form. Okay, one more quick thing. There are some special names for certain polynomials. A polynomial is a general term that encompasses every polynomial ever, right? But there's some special ones. If there's only one term, we call that a monomial. If there's two terms, we call it a binomial. If there are three terms, we call that a trinomial. And then if it's got four or more terms, we just call that a polynomial. We don't go beyond that. So I know I threw a lot at you real quick. Feel free to review, feel free to pause, do what you need to do. I am going to show you one more thing on this video. I'm going to kind of break this down a little bit and draw some arrows and whatnot to help us make a little bit more sense of this. All right, let's do a little diagramming here. Let's break it down. We know we have 5 terms here. I've labeled them. Term, 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 term. Those are the terms. They're separated by addition and subtraction signs. Next, we have coefficients. All 4 of these terms have coefficients. That's just the number in front of the variable, so it's the number that the variable is being multiplied by. They're labeled here in purple. The coefficient here is 5. The coefficient here is 2. This one's 2. This one's 11. And again, that one does not have a coefficient. There's no variable. Let's talk about that one. This is our constant term. It's the one that never changes no matter what the variable is. 3 is going to be 3 is going to be 3 all day long. The last thing I have labeled up here is the leading coefficient. That's just one of the coefficients, the one that happens to be up front, which is the one that is attached to the variable with the highest exponent. So our leading coefficient for this particular polynomial is 5. We cannot call this one a monomial, binomial, trinomial because there are more than 3 terms to it. This one we would just call a 5th degree polynomial. Hang on, that's not true. There are 5 terms to it. This one we call a 9th degree polynomial because that is the highest exponent involved. Okay, check out the practice problems. Let me know if you have questions. You got this.